already seen the two pictures here of the graph of the little man walking. We saw that earlier on the first day that we were learning about slope. But here we're just going to go a little bit further and deeper into what actually makes a horizontal line, what actually makes a vertical line. So let's take a look at this first example. So the equation is very simple. It's just y equals 7. And that's going to make a horizontal line that's passing through the y value of 7. And so this is always going to be the format of something that makes a horizontal line. Anytime you have y equals to a number, notice how there's no x shown at all. It's just y equals 7. The graph is going to be a horizontal line. Another thing about this scenario is that this is when the slope is equal to 0. And so the equation that we wrote earlier is actually the same thing as y equals 0x plus 7. We know that the slope is the number that's multiplied in front of the x in our equation. And so it's really equal to 0, but 0 times anything is 0. So if you have a 0 in front of the x, you don't even have to write the x there. All right, now let's take a look here at the equation for a vertical line. It's also a very simple equation, but there's one difference. Instead of saying y equals, it's going to be x equals. And so the x in front is telling us that it's passing through the x-axis instead of the y-axis, and that's going to make the line a vertical line. So what we see here happening on this graph is that the line passes through the x value of 3. So anytime we see that x is equal to a number, the graph is going to be a vertical line. And remember that that type of line does not represent a function. So if we think back to what we did in our very first lesson back in 2.1, we said, well, in order for it to be a function, each input, each x value, can only correspond to one y value. And if we look for the x value of 3, that's actually corresponding to an infinite number of y values. In fact, if we take a look at some of these ordered pairs here, we've got the point 3, 8, 3, 7, 3, 6, and so on, and it's actually an infinite number of those where we have the same x value of 3, but it's a different y value every time. So that's a little thing just to pay attention to. We can still write an equation for it, we can still make a graph, but not every equation and not every graph is technically a function. Also, the other scenario, the other thing that's true about dealing with a vertical line is that it doesn't have a slope. This is when the slope is considered undefined. And we saw this in a previous lesson with that little guy who's like falling down saying, help, he cannot walk on that line at all. So there is not a slope. All right, so the trickiest thing that students have with these equations is just remembering when is it horizontal and when is it vertical. Because it can be very simple to get these mixed up. And so going back to the first one, what I always think about for the horizontal line, because it has the variable y in there, it passes through the y-axis. And any line that's passing through the y-axis is going to end up being a horizontal line. All right, and then it's going to be just the opposite for the other situation. So if you have an x that's represented here in our equation, we're going to remember, okay, that is a line that passes through the x-axis. So whatever variable you see is the axis that it is passing through. All right, so with that introduction, there are 3 equations at the bottom of your paper that I'm going to have you practice. So go ahead and graph those 3 equations. We've got y equals 5, x equals -4, and y equals 0. One thing you'll notice here is we're still putting those arrows on the end of our line segment, so that's just implying that this line is continuous. It's going to continue going forever in both directions. The first one was y equals 5, so it's going to pass through the y-axis, so it's going to be horizontal. The next one we had x equals -4, passing through the x-axis is going to make it vertical. Now we had an interesting one here at the end. We're back to a y equals, so it's going to be horizontal just like the first one. But because it is y equals 0, well, if we think about where the y value is 0, that's actually right on top of the x-axis. So if we think about how the y values are labeled, we have like +1, +2 above the x-axis. Then we have -1, -2 below the x-axis. So what has to be right halfway in between is the value of 0. And so that's an interesting one. And by the way, if we would have reversed this, so let's say that we were wanting to do x equals 0, that's going to be right on top of the y-axis. It has an x equals, so it's going to be vertical. That y-axis position is right where the x value is equal to 0. All right, so that's a little bit about horizontal and vertical lines. These are lines that will continue to come up at various places throughout the year. So this is just kind of the first time that we're like officially defining how we do each direction. All right, so that's that part. Let's go ahead and turn your paper over to the back side. Bless you. All right, and so we're taking a look here now at a graph that has 3 lines. And using the graph here, we're going to write the equation for each line in slope-intercept form. So this is what we did last week on block day. So remember that slope-intercept form, it's defined by the slope and the y-intercept. So that's the form that we're going to write out as y equals mx plus b. And if we were to just take a look at the first one here together, I'm going to put a little subscript of 1 down there. So y1, I'm going to look at the line there, like furthest to the left. And I like to actually start by identifying the y-intercept. So that's going to be the point where the line crosses through the y-axis. So I can see that that y-intercept is 6. I'm actually just going to write a +6 here at the end. You could put your y-intercept at the front, but I like to put it at the end. And then to determine our slope, we want to identify a second point on the graph. So I can see there's another point here going through like the x value of 1 and the y value of 8. And then what we want to think about here is using rise over run to figure out the slope fraction. What is the slope ratio? So going from one point to the next, notice how we're going up 2 spaces. So the rise is 2, but then we're only going over 1 space. So the run would be 1. So technically to write this out, it would be 2 over 1, but that's really just the same thing as 2. So if you wanted to write the fraction as just a 2 instead, you can do that, but technically it's 2 over 1. The other 2 things we need to think about here, this is increasing as we go from left to right, so it should be a +2. Now this is invisible math here. You don't have to write the plus sign out in front, but imagine that there's an invisible plus sign there. The other thing that we want to be careful to make sure that we add is we don't want to forget the x part. On the day that we had learned this last week, when you all filled out that exit ticket for me, it was on a yellow piece of paper. Some students in the room had the correct slope, but they forgot to write the x behind it. If you don't have an x in there, then it's just going to be a horizontal line, because it's just going to be y equals 2 plus 6. Well, 2 plus 6 is 8. That's a horizontal line going through the y value of 8. It's just a little bit different altogether. So let's go ahead and have you fill in the next 2, and I'm just going to label them as y2 and y3. So take a look at those lines and put in what the equation would be. All right, so let's double check our equations here. So our second line, notice that this one had a y-intercept of 2, but we see that it actually has the same slope. So going from one point to the next, it's still up 2 over 1. The last one here has a different y-intercept of -4, but when we check the slope, it's still up 2 over 1. So these are our three different equations. So notice that they have different y-intercepts, so they're in different places on the graph, but they all have exactly the same slope. And so we can see that when the slopes are the same, if the steepness is exactly the same, these lines are never going to cross. And so the special name we give to that is we say that they're parallel. So parallel lines never cross. That's the first thing. And what makes it so that they never cross is that the slopes of those lines are exactly the same. So this fact right here is what we're going to need to use to move forward with the next couple of questions. You're going to see that we're being asked to write some equations given some clues, and the clues are now going to be related to thinking about lines being parallel. So let's take a look at our first question. So here we want to write the equation of a line that's parallel to y equals 3x minus 2. We also want it to pass through the point 2, 9, and we're always going to pay attention to the form that the question wants our answer in. We're going to be doing it in point slope form. All right, so let's break this down just one piece at a time. So let's start with this. Our equation is going to be parallel to this equation. So what's the slope of this equation? We're noticing here that it's 3. So our line slope is also going to be 3. Okay, so let's make a little note here. Our slope is also going to be 3. All right, so that's sort of the first piece that we know. Now, the y-intercept of the given line of -2, that actually does not have anything to do with us coming up with our equation. It doesn't matter what that is, because we don't need the y-intercept to determine how two lines are parallel. So I'm just going to make a little note here that we're going to ignore that part. We're going to ignore that -2. The only piece that we need is just to figure out the slope. All right, so now the question sort of changes. Now we know that our line has a slope of 3. We know that we want it to pass through the point 2, 9. And we're going to write the equation for our line in point slope form. Well, we're ready. We have all the information that we need to do that. Point slope form. So this is a little review of what we did on Friday. Let's go ahead and first write the general point slope form. So we have y minus y1 equals m times the quantity x minus x1. And then we'll just look at the pieces of where we're going to plug things in. So m is always our slope, so we're going to plug in 3 in that position. And then the x value for the point that it passes through is x1, and the y value for the point that it passes through is y1. The regular x stays there, the regular y stays there. So here's our final answer. We're going to say y minus 9 equals 3 times the quantity x minus 2. All right, taking a look then at our next example, it's really similar in the information it gives us. The only thing that's different is that now we want to do our final answer in slope-intercept form instead of point slope form. But the initial setup is going to be the same. So this one, we want our line to be parallel to this line here. What's the slope of this line? So that one is -5. I'm going to cross out that y-intercept part again. We can totally ignore that. We just need to figure out the slope of our line. So just as we did before, let's say our slope is also -5. All right, so using our slope and using the point that it passes through, I want you to go ahead and put it in point slope form. This is going to be an in-between step that's going to help us eventually get to our answer of slope-intercept form. So point slope form is just what we did in the previous problem. So all we need to do here to turn this into the other form is get rid of our parentheses. So that's going to be our first step. So we can do that by just distributing the -5. So it's going to become -5x plus 35. And then we want to get y by itself. So we'll just go ahead and subtract 3 from both sides. All right, so here's our final answer. So we've got y equals -5x plus 32. And by the way, notice that when we were subtracting 3 from both sides, I wrote that underneath the plus 35 part. We want to make sure that we're combining like terms together. Don't try to subtract that from the -5x, because the 3 doesn't have an x attached to it. So our final answer here, we can see, yep, it still has a slope of -5, but our answer now has a big y-intercept of 32. So really the process that we followed on these two problems were really similar. It just was going that extra step to get slope-intercept form if the question asks us to do that. All right, so that's all parallel lines. We're going to go ahead and turn our notes over to one more section, and we're going to finish up talking about perpendicular lines. All right, so we're actually going to kind of start off in the same way here. So I have a new graph with 2 lines, and I would like you again just to take a moment here to go ahead and write the equations down for the 2 lines that you get. You're going to go ahead and write those equations in slope-intercept form. All right, so I'm going to look at this one first, the one that has the positive slope. I'm just going to label that here as y1. So hopefully you saw here on this one we had a y-intercept of 1. So when I think about there being a plus 1 at the end, slope-intercept form, y equals mx plus b. And then going from one point to the next, I see that I'm going up 2 over 1. So this is actually going to have that same slope of positive 2 that we saw on the other page. We definitely have a different kind of scenario, though, for the other line over here. First off, because it's decreasing from left to right, I can see that the slope is going to be negative. And then it's also going through a different y-intercept, so I'm just going to go ahead and put that y-intercept here of -4. And then I know that the slope is negative, so I'm going to put a negative sign here in front of that slope part. When we do the rise over the run here, notice that now it's going to be a different fraction because we're only going up 1 space, then we're going over 2 spaces. Up 1 over 2, up 1 over 2, up 1 over 2, and so on. So the rise over the run is now 1/2. Now the 1 is on the numerator and the 2 is on the denominator. Same as what we talked about before, don't forget to put that x in your equation after you put in your slope. All right, so a couple of things I want you to notice here. First of all, we can see the perpendicular lines absolutely do cross. There's something special that happens when they cross. They form a perfect 90-degree angle. It's a little bit harder to see with them being tilted, but if you were to think about like tilting it this way so that it's like a horizontal line and a vertical line, 90 degrees, that's what perpendicular lines do. And then let's notice something about the slopes here. So first of all, our slopes are absolutely not the same, but they do have some things in common. Notice how our first slope of 2, we just wrote it as a 2, but technically it was 2 over 1, up 2 spaces over 1 space. So if I were to rewrite that with both parts, notice that between the 2 over 1 and then the 1 over 2, these are just flips. We call them reciprocals when the numerator and denominator switch places. So that's one thing I want you to notice, is that the fraction part, they are reciprocals of one another. The other interesting thing is that they have opposite signs. So one of them is positive and the other one is negative. And so the term that we use to describe what the slopes are, there's two things going on here. We call them negative reciprocals. And I'm just going to put right here above the example of what we saw right here in this picture. We had positive 2 over 1, and then we had negative 1 over 2. So if you were trying to find a negative reciprocal, all you need to do is change your original slope that you've been given to the opposite sign. It's kind of like putting a negative in front. So like if you put a negative in front of this one, it becomes negative. If you put a negative in front of something that's already negative, it turns positive. So the signs are opposite, and then we're just going to flip the numerator and denominator. So thinking about negative reciprocals, we're just going to do a little practice here just with the slope part. So I'm just going to have you answer question 3. You're going to find the negative reciprocal of the following slopes. So think about the slope that's been given to you. What would be the slope of a line that's perpendicular to that line? All right, so the first one we were given, it was kind of like one that we had in our example with a 1/2, but notice how this one was positive. So we're going to go ahead and make it negative, and then we're just going to flip the numerator and denominator. Negative 2 over 1, or you can just write it as negative 2. In the second one here, it's really the same thing as negative 5 over 1. So when we do the reciprocal, it's going to turn into 1/5, and we're going to make it positive. It was negative. Think about putting a negative in front. So positive 1/5. The last one here is also going to turn into a positive. We're just going to take the reciprocal here, so it's going to be positive 4/3. All right, so that is really the only thing that makes our final 2 problems different from what we did earlier. Instead of looking for the parallel slope, which is the same, the perpendicular slope has to be this negative reciprocal. Otherwise, our steps are going to look really similar. So here we're going to write the equation for a line that's perpendicular to this one. It's passing through a given point, and we're going to do this one in point slope form. I always think that's the easier one, so I like this question. So looking at the equation that they gave us, that slope was negative 1/3. I want you to go ahead and write on your paper what would our slope be. So if that one is negative 1/3, I want you to write down what would be the negative reciprocal for that. And then I want you to turn to a partner here at your table and check your answers. So see, did you write down the same thing for the perpendicular slope? All right, would someone be willing to share out? What did you get? Go ahead, Josh. Just 3, awesome. Yep, so it's really 3 over 1, which is just the same thing as 3. And we need to make sure that it's positive, because it needs to have the opposite sign of this one. Okay, so at this point now, like we're definitely not doing anything with that +7. We can ignore that. And actually, once we figure out what our slope is, like technically we could ignore that one as well. We needed it to figure out that our slope was 3, but we're not utilizing either of those pieces now in getting our final answers. All right, so now it's going to pass through the point negative 2, 5. We're going to put this in point slope form. So we're going to do y minus the y value of the point that it's passing through. And then we're going to do equal sign. And then our slope of 3 is going to go here in front of our parentheses. In our parentheses, we're going to do x minus the x value of the point that it's passing through. So really, it looks like x minus -2, but that's really the same thing as x plus 2. So let's just go ahead and turn it into a plus sign. All right, and that would be our final answer here. We don't need to go any further. We wrote it in point slope form. That was the form that our answer needed to be in. All right, we have one last problem here on the page. And this one is just going to be slightly different because of the perpendicular slope to the one that they've given us here. So let's recognize here that the given equation had a slope of 4. Again, on your paper, I want you to go ahead and think about what slope would be perpendicular to a slope of 4. Go ahead and write that down. All right, so there's two things that we're always checking. So let's go back to our given slope here. So that's really the same thing as 4 over 1. So you can always write something over 1 if you don't see the denominator part. So two things happen. When we flip it, when we get the reciprocal, it's going to turn into a fraction. So it's going to turn into 1/4. Also, it needs to be the opposite sign. It's just like putting a negative in front of what we originally had. So our slope is now -1/4. All right, so this +6 over here, definitely ignore that. We're not doing anything with that. Also, once we figure out our slope, we can also ignore what the original slope was. And in order for us to get slope-intercept form, let's do the same strategy that we did before of putting it into point slope form first. So that's always going to be our in-between step. So looking at the point that it's passing through, we're going to do y minus 1 equals -1/4 times the quantity x minus 3. All right, now we need to do a little work with this to turn it into our slope-intercept form. So we're going to do two things here. We want to get rid of our parentheses, and we want to get the y by itself. All right, so here we're going to see a fraction being distributed to the inside. So let's talk about that. The first part is not too bad. We're just doing -1/4 times x. So that's just going to be -1/4 x. Let's talk about the second part here. So first off, when we do a negative times a negative, the answer is going to be a positive. There's no plus sign yet. And when we're doing a fraction multiplied by another number, what we want to do is think about having a numerator and a denominator for both pieces. Okay, so we have the 1/4 in front. We want to multiply that by 3. Well, that's really the same thing as 3 over 1. It's not the same thing as 3 over 3. If you make a denominator 3 over 3, that actually simplifies to 1. So make sure that we're doing 3 over 1. We talked about this last week, but multiplying a fraction by another fraction, this is the easiest fraction operation to do because all that happens is we just multiply across the top and we multiply across the bottom. So that's going to turn into 3/4. So that's going to be our fraction that we have here at the end. All right, we got rid of our parentheses. The last thing that we need to do here is get the y by itself. So we need to add 1 to both sides. All right, so that's going to cancel everything out here on the left. We can actually bring down the -1/4 x part. So that's going to stay the same. What we need to talk about now is how to add 3/4 to 1. Because this is just a nice whole number here, one way to think about it is it's going to be 1 and 3/4. But keeping it all in terms of a fraction, when we're adding a fraction to a number, we want to get our denominators the same. And so looking at that 1 at the end, Well, we can actually turn that into a fraction. It's really the same thing as 1 over 1. In order to get our denominators the same, we can keep the first one as a 4. We can turn the second one into 4. So if you multiply the denominator part here by 4, we also have to multiply the numerator by 4. So it's really just 3/4 plus 4/4. When we're adding fractions, it's not the same thing as multiplying. So we do not just add across the top and add across the bottom. Instead, we're only adding across the top. That common denominator that we got of 4 is just going to stay 4. So altogether here, this would be like a 7/4 at the end. And that would be our final answer here.